Hello again. We're starting up lesson 9 today. Okay, adding and subtracting radical expressions. Now, when we do addition and subtraction of radical expressions, we're going to want to make sure that the radicands, in other words, the number inside of the radical, match. They have to match. You cannot add radicals that do not have the same radicand. Okay, so in other words, if we have, let's say, radical a plus radical a, then we can do that. We can do twice radical a because it's two of them. But if we have radical a plus radical b, then that is not equal to radical AB. Okay, you don't combine them together. All right, the only way you can combine them together is if the radicands match, and also, of course, their indices. Their index has to match too. In our case, it was a 2, but if it's a cubed root, fourth root, they have to match. Okay, so the power, sorry, not the power, the radicand and the index have to match in order to add. Okay, so I'm going to put that right here. Okay, so the radicand and index have to match. So radicand and index have to match. So if anything, let me put this in blue like I put right there, and the radicand in yellow like I did up on top. So okay, let's go ahead and start off. We only have 5 examples. This is going to be relatively quick, maybe not too fast, but relatively quick. We'll see. So example number 1, what we're going to do here is, all right, so this first problem we're going to do, we're just going to be simplifying. Actually, all of them we're just going to simplify. So part A, square root of 28x plus the square root of 63x. So we want to try to simplify as much as possible, and hopefully the radicands match. You'll notice the index is a 2. That means it's a square root. So this is 4 times 7x, and this is 9 times 7x. Now I know that 4 has a nice square root, it's a 2, and 9 has a nice square root, it's a 3, so I'm going to write that out. This is 2 radical 7x plus 3 radical 7x. So now that they have matching radicands and I can't simplify anymore, all I'm going to do is add the numbers in front of the radicals. Those are the coefficients for that radical. So 2 plus 3 is 5. So my answer is 5 radical 7x. And that's my answer for that problem right there. Okay, now we'll try another one very similar to this. Part B, negative 4 cubed root of 16 plus the cubed root of 54. Okay, so I'm going to think of numbers for this that actually give me a nice cubed power. Okay, unless you know the cubed root of 16, which doesn't exist, or the cubed root of 54 also doesn't exist, but we can break it down. So here we go. This is negative 4 cubed root. Now 16 is 8 times 2, and I know 8 has a nice cubed root. It's 2. Okay, so 8 has a nice cubed root. Now 54 is 27 times 2, and 27 has a nice cubed root. It's 3. So this 8 will come out, and this 27 will come out. Okay, so the 8 comes out and becomes a 2, so it's a negative 4 times 2 cubed root of 2 plus a 3 cubed root of 2. Let me simplify real quick. That's negative 8 cubed root of 2 plus 3 cubed root of 2. So negative 8 plus 3, that's 5. negative 5, sorry. Notice how the radicands and the index, they match up, right? Notice this matches that. This radicand matches this radicand. So that means I can add these things together. So this is a negative 5 cubed root of 2. And that's my answer. Just kind of putting it together. Okay, so that's another one. All right, a little bit tougher. I'll give you one that's a little bit less difficult. So we'll try 3 radical 45 minus radical 50. So this is a square root. I got to break this down into numbers that have square roots. So 45 is 9 times 5. 9 has a nice square root. And 50 is 25 times 2. Okay, so this 9 will come out. This 25 will come out. So I get 3, and then the square root of 9 is 3, so times 3 radical 5 minus the 25 comes out as a 5 radical 2. Okay, so 25 radical 2. Now let me simplify here. This is 9 radical 5 minus 5 radical 2. Now you'll notice the indexes match. Okay, that's an index of 2 and 2, but the radicands do not. So that means that I can't add these together. So if I can't add them together, then all I did was simplify them, which is okay, and I put them in their simplest form, and there's my solution. All right, so we just got 2 more of these, and then we're done with this lesson. So part D. Part D is 2v squared. Now these are going to be kind of tough, okay, so bear with me here. 32 vu squared plus u square root of 8v to the 5th. Okay, so this is actually the hardest example, and the next one's going to be a little easier, but this is actually the hardest example in the whole lesson. Now, the 2v squared right here and the u right here, those are just going to stay there for now, but we got to fix those square roots. Okay, so this is going to be 2v squared. Now 32, I know, is 16 times 2. Gotta be careful here. I don't want the 2v squared to look like an index. 32 is 16 times 2 vu squared plus u. 8 is 4 times 2, and v to the 5th is the same as v squared squared times v. Okay, that's v squared squared. That's v to the 4th times v. That's v to the 5th. So it's just another way for me to write these things out. Now notice how the index of a 2 matches this power. Now 16 we know is going to come out, but that comes out. And then this index matches this power, so the v squared will come out, and we also know that the 4 will come out. So the 16 is coming out no matter what, so is the 4, but we have matching index and power, so those are going to come out too. So let's write that out. This is 2v squared times, well, the 16 comes out, that's a 4, times, well, the u squared, the u will leave. So there you go. So all that's left in there is this 2 and this v. So square root of 2v plus, I'm going to put a u here, times a 2, because that's the 4. That when the 4 comes out, it becomes a 2. And then a v squared, and then square root of 2v. Okay, so I mean, very messy. Okay, but notice I can still simplify here. I have a 2 times 4, that's 8 v squared u radical 2v plus 2v squared u radical 2v. Now I do want you guys to notice, same index, same radicand. That means I can combine these things, okay? I can combine them just by adding, if possible. Now notice 8v squared u and 2v squared u are like terms, so if I add them together, I get 10v squared u radical 2v, and that's my solution for part D. Okay, so that's going to come out from that. You can kind of combine everything together in the end. Now this one's very complicated. You got to kind of take your time, bring things out slowly. Okay, don't try doing everything all in one step. And like I said, that was probably the hardest problem. Now here's E, which I don't think it's a difficult problem, but it kind of looks like it's going to be because of the fact that it's a longer problem, but not too difficult. So here we go. This right here, 4 radical 9 times 5 plus 2 radical 5 minus radical 4 times 5. Okay, notice I didn't break down the 5 because I can't. I don't need anything. This 5 right here just stood the way it was. But the other ones I broke them down. Now, I know that this 9 can come out. Square root of 9 is 3 and the square root of 4 is 2. So I can bring these things out. So this is going to be 4 times 3 square root of 5 plus 2 square root of 5 minus 2 square root of 5. That's 12 square root of 5. Now positive 2 square root of 5 minus 2 square root of 5 is 0. So this actually just cancels out. So here's my answer, 12 square root of 5. So hopefully this stuff made sense. And again, if it didn't, please let the teachers know, let your instructor know, and we'll be able to help you guys out, okay? So have a good day.